All right, guys, today, kind of continuing on with powers and exponents, we're going to talk about something that more than likely you haven't seen before, negative exponents. So what I'd like you to do is to go ahead and quickly, please, take out your binders and flip over to your notes section. So green on the left, notes on the right. Negative exponents. We do have one vocab phrase here. So green on the left, notes on the right. Okay, so in your chapter 4 notes here, negative exponents, the one phrase or the one word, actually it's a phrase and that's exactly what it is negative exponent. Everyone? Okay, so your book, here's what it says about negative exponents. It says negative exponents are the result of repeated division. Okay, so a regular exponent, right, is repeated multiplication, but this one's repeated division. So if you take a look on your little box to the side, you can go ahead and write this down. This looks a little weird, but 4 to the negative third is equal to 1 over 4 to the third. So if you don't want to write that, you can write this. 4 to the negative third is equal to 1 over 4 to the third. Now you might look at that and say, wait, what? How does that work? Well, let me explain this to you. All right? And you're more than welcome to write this down if you want, okay? But if I make a little chart, it's best shown in a chart. Move this up a little bit. In this chart, let's go ahead and say all right, so let's say we have something like 10 to the third power. All right, now 10 to the third, which is 10 times 10 times 10, okay, of course gives us 1,000. Now, 10 to the second power, right, is 10 times 10, which gives us 100. 10 to the first power, of course, is just 110, and that's there. Now, what many of you guys will say is, well, Mr. Wilkins, what's happening is the zero's disappearing. Well, yeah, you're right. 1 0 is disappearing, right? Now, this is a little weird. 10 to the 0 power, if you take a look, if you keep up that idea of a 0 disappearing, you're going to end up with 1. And that's exactly what 10 to the 0 power is 1. However, what's really happening is this. There's a decimal point here. It's actually moving over to the left once, which of course moving a decimal point over to the left is division. We're actually dividing by 10 every single time you work downwards. Divide by 10, divide by 10, divide by 10. Okay. Now, with that said, if we continue this pattern, we now know it goes 3, 2, 1, 0, and then negative 1. If we continue this pattern, here's what we're going to have. We're going to have the decimal point moving one more to the left. What that is 1/10 as a fraction and as a decimal. If we continue this, 10 to the negative second power, this is shifting over again. So now we end up with 1/100th. And if I write that as a fraction, there it is. Now, I'm going to take this second and show you what we have here. What we have, if you didn't realize it, is 1 over 100 is actually 1 over 100, right, is 10 squared. Let me show you something. Let's go one more. 10 to the negative third, right? What do we have? 2 zeros with the 1, or 1,000th, which is 1 over 10 to the third power. So if you're looking at this, here's what's happening. To make it a little easier on yourself, compare these two. Or compare these two. How are they different? Well, in reality, if we're just not looking at the whole concept, we're just looking at patterns here, for example, 10 to the negative second power, all that's happening is basically this negative power is creating a numerator of a 1. And of course, the denominator is without the negative, 10 squared. So 10 to the negative second power is really 1 over 10 to the second power, positive second power. 10 to the negative third power is 1 over 10 to the positive third power. So if you want to think about it this way. It's almost like these two are squishing together and the negative is popping out and becoming a numerator of 1. I know that's a little weird to think about, but that's kind of what's happening here. And why? Because of the repeated division of that chart. So we're going to use that idea and we're going to go ahead and solve some of these problems. So here we go. Let's go ahead, and if you haven't done so already, go ahead and grab your book, all right? And we're going to work on some examples. Flip your book over to page 143. Go ahead and grab your piece of paper. Get your name, date up at the top, your period, assignment number. Okay, so here's what we're going to do. If you haven't flipped your book over to 143, page 143, I want to start with actually just doing a problem for you. So you can go ahead and put your pencils down and just watch. This is just review of what I was just talking about. So on page 143, number 14, the direction said, write each expression using a positive exponent. And here's what they give us. What is 11 to the negative 6th power? And remember, they're just wanting us to write this with a positive exponent. So here's what they want. Remember what I said? The denominator, it's like 6 is squishing over to the 11. So it's 11 to the positive 6th power. And the numerator, this negative, is becoming a 1. And that's all that we're going to be doing with this type of problem. So here's what I want to take a look at. We'll go step by step on number 18 here. Okay, number 18, same kind of problem, but what we have this time is we have a variable, a to the negative 2nd power. All right, so here we go. You can almost say this is 2 easier steps here. So we could just say, considering this type of problem, step 1 is you're taking the negative and making that a numerator of a 1. And then step 2 is you're taking the leftovers, you could say, which is a with the positive 2 squared. I'm sorry, positive 2, a power of positive 2, or squared. So, and that is a squared. 1 over a squared would be how to write that with a positive exponent. Okay, so here's what we're going to do. This next problem I'm going to give you, I'm going to have you guys try it out using just those 2 steps. Shouldn't take you very long. All right, go ahead and same section, same type of problem, number 20. I'll give you 30 seconds. Go. Okay, go ahead and turn to your neighbor and share your answer. 30 seconds, go. Okay. More than likely, you didn't even need 30 seconds to share that with your neighbor. So here we go. We have b to the negative 15th power for problem number 20. So here we go. Step 1, right, is the negative shows us that we have a numerator of a 1. And step 2, take what's left, or in this case, it's b to the positive 15th power. And there's our answer. Okay, so there are 3 different types of problems you're going to see on tonight's homework. So that's one type. All right, the second type. Let's go ahead and you can put your pencil down now. I'm going to do another one for you just to watch here. So on the same page, 143, but let's take a look at problem 24. Okay, problem 24 is a different type of problem. The directions say write each fraction as an expression using a negative exponent other than negative 1. All right, so it's kind of wordy. Here's what we're going to do. Okay, problem 24 shows it like this. 1 over 7 to the 6th power. Here's all they want you to do. They want you to just do this problem, but work the other way. All right, so if you're going to do this, here's all you do. Remember, 7 to the 6th power? But the numerator of a 1, of course, creates the exponent of negative 6. And that's all they're having you do. All right, so here's what I'm going to have you guys do now. Let's go ahead and grab our pencils and let's together do this problem right here. It's number 26, 2 problems later here. Okay, this one is 1 to the 4th power. Now, with this one, there's a little extra step here because it's been simplified. So it's almost like we need to write this in exponential form, and that's what step 1 is. So go ahead and write the denominator, the 4, in exponential form. So the numerator stays as a 1. 4 is just easily 2 squared. Okay? Step 2 is go ahead and take the denominator, rewrite it down. This is 2 squared. However, we're going to go ahead and use step 3. We're converting this fraction, right, into a negative exponent. So the 1, or the numerator of a 1, becomes a negative. So we have 2 as our base and a negative 2 as our exponent. 2 to the negative 2nd power. Okay. So I'm going to have you guys try one. 30 seconds. Try out problem number 28. 28. Go. Okay, go ahead and turn to your neighbor and share your answer. Go. Okay, number 28. They give you the problem. Move it over here. The problem is 1 over 144. Okay, so a little more challenging than the one we just did together, but it's the same idea. So here we go. I'm going to go ahead and keep my numerator of a 1. Step 1, right, is we put it in exponential form. In this case, we could just say 144 is 12 squared. 12 times 12 is 144. Okay. Step 2 is rewrite the denominator here. Oops, I probably shouldn't have written that. We'll use that as an arrow. All right, and I'm going to go ahead and write it as 12 squared. And then step 3, right? The numerator of a 1 creates our negative exponent. So we have 12 to the negative second power. Oops, sorry. There we go. 12 to the negative second power. Okay. Now there is one more problem. We're just going to take it a half a step up. So here's what I'd like you to do is let's go ahead and flip the page over to 144, just one page, and let's take a look at problem number 34. Okay, on problem 34, they give us a problem that is p to the negative third power. Now the directions say evaluate each expression if n equals 3, p equals negative 2, and q equals positive 6. All right. So, you can do this one of two ways right off the bat. Is we can go ahead and we can plug in the number for p right now, or we can convert it to a positive exponent first. So, with this one, right, I'm going to go ahead and say step 1, I'm going to convert it to a positive exponent first by making my numerator of a 1 for my negative. So it's 1 over p to the third power. Now, step 2 is I'm going to now go ahead and plug in my number, all right, for p. So I'm going to go ahead and taking a look. The p is negative 2. So I'm going to go ahead and say negative 2 to the third power with parentheses. Okay, now step 3 is I'm going to go ahead and simplify the denominator. So I have 1 over, and then this is negative 2 times negative 2 times negative 2, which of course this is negative times a negative is a positive 4. Positive 4 times a negative 2 is a negative 8. And we have 1 over negative 8, or negative 1/8. Okay. So I wrote the steps on that one. It's going to be the same steps on this next one here. I was planning on just doing that. So we'll go ahead and write the steps on this next one. So here we go. Number 38. Number 38 is 6n to the negative third power. So, remember what I said. Step 1, I can convert it to a positive exponent. Now, be very careful. This here is this coefficient of a 6 is actually different than this whole thing here. This n and negative 3, the negative 3 goes with only the n, not the 6. So we have this, and we say, okay, well, that means that this is 1 times n to the positive third power. So that is step 1. It's the same thing we did earlier. Okay. Step 2. All right. Remember, step 2 is I'm going to plug the number in. So it's still 6 times, and then 1, and then n, it says, is 3. So it's, in this case, 3 to the third power. So now I'm going to simplify. I tell you what, I'm going to simplify my exponent first. So I'm going to keep my 6 up front, and I have 1 over, and then 3 to the third power is 3 times 3 times 3. Okay, well, 3 times 3 is 9, times another 3 is 27. Now this isn't done being simplified. What I'm going to go ahead and do, I put my 6 over 1 times 1 over 27, and I keep simplifying. 6 over 27, and like any other regular fraction, I'm going to reduce if I can, and I can on this one by 3. So 6 divided by 3 is 2. 27 divided by 3 is 9. And that is my answer. Alright. Got a little close there with this, so let me go ahead and split it up with a blue line where you can see the change. So step 1, right, was change it to a positive exponent. Remember, 6 is separated from the n to the negative third. That's why the 6 keeps going here. Okay. Step 2 is plug my number in using parentheses. So instead of the n, I'm plugging in the 3. Step 3 at this point is simplify. So I simplified the 3 to the third power, and then I had to simplify by multiplying across and then simplify or reducing even further. Okay, so here's what I'm going to have you guys do. This will take a little longer. I'll give you guys 1 minute. Go ahead and try out problem number 40. Go. Okay. 30 seconds. Check with your neighbor. See if they agree with you. Go. Okay, so when I'm going to solve this problem, I have, this is a little different, right? 7 to the p power. Well, remember, right? We're going to plug a number in for that, and then q squared, or q to the second power. Now, if we're talking about step 1, getting rid of negative exponents, there are no negative exponents, at least not yet. So in this particular problem, we have to do what I said earlier, have to be a little flexible, is we have to pretty much do step 2 before step 1, meaning we're just going to plug numbers in for the variables first. All right, so here we go. So this is 7 to the p power. Well, what was p? If I look here, p was -2. So it's 7 to the negative second power. And then we have q, and q was 6. So I'm going to plug in the base of 6 to the second power. All right, so now I guess we could do step 1 next, right? And that is, I'm going to go ahead and simplify this. Now remember, this is 7 to the negative second power times 6 to the second power. So I'm going to go ahead, I'm going to change all my negative exponents to a positive exponent. So I'm starting with this first one here. 7 to the negative second becomes 1 over 7 to the second power times 6 squared. And then I'm going to go ahead and simplify. Well, let's go ahead and simplify this one first. This is 1 over 7 squared. Well, that's 7 times 7, which gives us 49, times 6 squared is 6 times 6, which is 36. Or you could think ahead and put 36 over 1. When I multiply, of course, I get 36 over 49. All right, and looking to reduce, but there's no way I can. 49 is divisible by 7, but 7 can't go into 36. That is our answer. Okay, so that's tonight's homework, or today's lesson on negative exponents.